Welcome back. Well, today I'm going to be looking at audio again, and if, like many people, you've got your myRio and it's running a small robot or something like that, it's quite easy to send back the images, perhaps, relatively speaking, through Wi-Fi or whatever. But what about the sound? How do we stream the sound? Well, what I'm going to do today is show you how to stream using the stream command in the National Instruments library, which is a kind of special one. Now, you can stream using TCP or UDP or something like that, and that would be okay, but the stream command is supposed to be a little bit better. It's in that it can wait for more samples before it sends them. It's a little bit perhaps more efficient, although I'm not an expert in that. So to demonstrate this, what I'm going to do is I've got my myRio here run off a battery, so it's not actually connected to any sort of external wires other than just the battery, and a radio is streaming into the audio input, feeding straight in, which is switched on at the moment. So it should be transmitting through the Wi-Fi. Although I could get it to transmit through its own Wi-Fi, because it's got its own SSID. I'm actually using my my own personal Wi-Fi here on a sort of personal VPN. So, what about the program? How do we do it? As I say, there's a couple of ways to do it. The first thing you need to do is you need to use the FPGA, and you just need to fire the input data from the left and the right, because it's going to be in stereo, into a FIFO. And how we do that is the data that comes in is 16-bit per channel, and we stitch them together into a 32-bit word here. We can scale them a little bit so you get a little bit of gain in the input, and then put them into a FIFO. You can call it what you like here, which is first in, first output memory, which has got to be, of course, 32-bit wide. If you don't do that, you just get mono, as I found out. And you just keep repeating this sample by sample indefinitely, really, but you've got to do it at the right interval. And if it's hi-fi, then you've got to do 44.1 kilohertz, which is compatible with all the CDs and so on. And that works out to be 907 ticks. And you can work that out from 40 megahertz, 40 times 10 to the 6, divided by 44.1 times 10 to the 3. And that should give you 907 ticks of the 40 megahertz clock is your sampling rate, really. So you go ahead and do that. There's the front panel of the FPGA. Compile it. I've already compiled it, so it shouldn't really do anything. Then, as I say, you've got a choice really how you're going to fire the data up to the, in this case I'm going to stream it to a PC. It's going to be this Surface Pro again, and the reason is, rather than my other PC, is I can get access to the firewall, which I can't on my university PC, which they sort of stopped me doing that. But if I look at the Rio, so this is on the real-time processor on the Rio. It's the usual kind of thing for accessing the FPGA. This is you open a reference. Of course, you have to know the IP address of what you're opening. That's run on National Instruments Macs. You can get that information. And then you set up all the data you put in, which in my case is just the gain on the input, and the sample rate and ticks. Those are the things on the front panel of the FPGA code that you're running. And I've got 30,000 sample depth. Tell it to start and run, and we take 500 samples at a time here from the FIFO. And this is the key to it all. The stream command looks relatively simple, though I had a lot of trouble from it. So you're feeding in 500 samples, the buffer length. You have to tell it what type you're feeding in there, and I'll explain in a minute about the URL. Then you feed this one here. It's called the Create the Network Stream. This one, and then this guy here is you write the elements to the stream, and then you flush the stream and you can close it afterwards. That's recommended. As I say, it's not the only way to do it. You could use TCP or UDP, but if you're going to do that, you have to send it in string format, I believe. Well, I've tried that, and that works okay as well, but you have to flatten strings and then unflatten them at the other end. And I believe, I'm led to believe, it's not as efficient as doing it this way with the sort of patented National Instruments method. So I see a lot of people on the internet asking, how do you stream the audio, and people trying it and not very successful. I tried it myself without the FPGA, and it's really not much good without the FPGA and the FIFO. So go to the front panel though, and you'll notice that I have to supply the IP address of the PC, which I can do with IP. I can find out that from command window and just type ipconfig, and I can get that. So in my case it's 192.168.0.100. That's, when I say the IP address, that's given to me by my own router on a private network, so nobody else on this network, and I have to put /reader after it. So that tells me where the reader's going to be, and the reader's going to be on the PC. I don't have to, obviously. I could send it to another PC if I wanted to, provided the firewalls aren't stopping it, but I'm going to send it to, obviously, the PC I've got it connected to. And on the PC itself, what you have to do there is you use the sound commands. You set up your audio, set it for 44.1 kilohertz, and stereo 16 bits. Set a buffer up there, you get volume control, and then you label this reader and set the buffer again for the streaming, which is 500 samples. That's coming off the FIFO. And then you just basically read the multiple elements from the stream, this one here. But remember, we stitched together two 16-bit words, which isn't kind of right. You can't just stick that into the sound output thing, so you have to split it apart again. So we split it apart here with this guy here, which is the split number. There's probably other ways to do this. Of course, you could use two separate buffers if you wanted to. This is quite a good idea, this one. And then we just create this thing here, which is you know, the data going out, really, and it goes into the sound output VI, and we should be home and dry. When I first tried this, I could send data to the myRio, but I couldn't get data from the myRio back to the PC. And again, that was a firewall problem. So I do suggest, if you're testing it, it's on a local network, not connected to the internet. Turn off your firewall first, and then you've got nothing to worry about, and you'll know at least if it's possible to do it or not before you go back in again. So let's have a play with this. You also notice that you need the writer URL. I found, according to the instructions of the streaming protocol, you should only need one or the other. You should tell it where the reader is, or the reader should point to the writer, but I couldn't get it to work unless I used both IP addresses for some reason. I haven't seen that information written down, but in this, although in other cases when I tried test programs between PCs, I didn't need to do that, but for some reason on the myRio I ended up having to do both before I could get it run. So I'll run the which one's that? That's the main one. I'll run the real-time one first, and now I'll run, because the FPGA one's already running, I'll run the PC. There we go. Now we've got full stereo coming through the speakers of the this little Pro Microsoft Surface Pro, and I can tell you the quality is really good. I mean, it is sort of as good as the source, obviously, and this is where it's coming from. And just to prove it, I can. Oh, that's it, because it's coming from a radio. Okay.
who is on a concert sabbatical now. She's been a very busy woman.
Okay, so I'm going to turn that off just for a second. So just to summarize what we've got here, we're using streaming, and we've got a project called Stream, and we've got an FPGA, which I explained, which just takes the data from and puts it into a FIFO buffer after stitching the two channels together into a 32-bit word. There's the buffer, audio in FIFO. And then at the next level, I close that, we've got the writer from the Rio. That's the Rio program, which takes the data from the FIFO and puts it into the stream. And then finally we've got the PC. So there's sort of three levels. We're using all the levels really here. You have to have the project. You can't do it without having this project. Everything sort of combines together. So if you want to get sound from your robot or whatever you're working on, recommend perhaps using streaming. One thing I did notice though is that the input to the audio in, you need a bit of a preamp. You can't just stick any old microphone in there if you want to do your own. That's why I've used a sound source. It's got a bigger signal strength. So you really need some sort of preamp if you're going to use a microphone in there. That's my experience. I know there is a kit and there's a microphone that comes with the device, but I haven't got that. So there you go. So see you next time. Bye bye.